Okay, it is section 6.3, feature scaling. Feature scaling is a method used to standardize the range of features in the data. It is one of the data normalization methods in a broad sense. It is generally performed during the data pre-processing step. There are some scale invariant algorithms such as decision trees and random foresters. For those algorithms, you don't need feature scaling. However, most of other algorithms perform better with feature scaling. There are two common approaches for feature scaling. In min-max scaling, which is called normalization, we try to get maximum and minimum for each feature column. For jth feature column, the maximum, minimum, and we measure the ratio for each value. Then resulting values will become between 0 and 1. Minimum will be 0 and maximum will be 1. In standardization, for each feature column, we measure the mean and standard deviation and perform this operation. Then the transformed data has the standard normal distribution, which means that the mean is 0 and the corresponding standard deviation is 1. Okay, we have a remark here. Standardization is more practical than the min-max scaling for many machine learning methods, particularly for optimization algorithms. We have here two reasons. For many linear models, we can easily initialize the weights to 0 or small random values near around 0. The standardization possibly results in the optimal weight small, so the initialization can be more effective. Here, list number 2. Standardization makes regularization perform more effectively. And regularization is with a penalty term. The minimizer of the penalty term is 0. When the original W star is far away from 0, then here the penalty term may here result in very far from original the weights, so that maybe the accuracy will be lowered. However, once the original W star is near around 0, then now along with the regularization technique, it'll work very effectively. Okay, that's the end of the section. Thank you.